To start setting up conditions and calculations, I think we need to look back at our sets and sequence area and take a look at these cull components. Eventually, you might have a situation where you do some analysis or set up some condition and you want to remove items from a list or a data tree. And these components are pretty helpful as well as here in sets list and dispatch. So let's take a look at them. I'll set up a point grid. This time I'll use a little bit of my knowledge with data trees to make that a little bit faster. I'm going to go to vector, point, construct point. To this, I'll add a sets sequence series. Let me plug this into X and into Y. And you'll see that we just get a diagonal line of points here because we have 0, 0, 1, 1, 2, 2. The same inputs are plugged into both. If I think to the data trees that we've been looking at, I could do something here to make a grid just with these components instead of having to go, for example, to transform an array to do that. What I'd need to do is somehow make this component repeat the operation several times. To do that, I could, for example, right-click on X and graft. What's going on there? The component sees that in X it has now several lists, and in Y it has just one list. It's going to start at this list, it has some point, and it's going to repeat the creation of a point for every number plugged into Y. And it's going to continue that until it finishes with all the lists that we have in X. Grafting helps us out. And if we look at display, vector, and point list, we see a little bit how the points are ordered. Let me make the size of that a little bit bigger. Right click on S, set number to 0.5. There we go. And the point list component is coloring our different branches. See that there? I actually don't need this data tree information. I just wanted a quick way to make points. So let's go ahead and right click here on point and we'll flatten it. Flattening removes all of that data tree information. Now we just have one long list, and you'll notice that the cable is showing us that we're transmitting a list, whereas before it was transmitting a data tree. And we just need the list version, so we right click there and flatten. All right, what I wanted to actually show you was here in sets, sequence. I want to start here with call nth. If we plug this point list into here, and we look at what's plugged into n, we'll actually notice that now we've treated the list, we've filtered the list based on this component. So it's removing every nth element from the list, which in our case is set to 2 by default. It's keeping the first point, removing the second point. Keeping the first point, removing the second point. It's just a quick way to filter out every other value. We can change this, for example, if I create a panel here, double click on the canvas, quote, and I type in a 3. Now I'm going to remove every third element. I keep, remove, keep, remove, keep, remove. That generates a pattern. That's useful if you know that every third element needs to be removed. Oftentimes, the pattern's not going to be so regular. You might need to generate your own pattern of true and falses, and that can come from some analysis or some calculation. In that case, I'd use something like set sequence and call pattern. Let's see how that works. Plug in our point list into L. In P, you have a Boolean pattern. So this is a pattern of true and false values. By default, it's set to false, false, true, true, meaning that I'm removing 2 and I'm keeping 2. Let's see how that looks like over in Rhino. I remove the first 2, I keep the second 2. False, false, true, true. False, false, true, true, etc., until we run out of things to filter. Of course, we can edit this list if we go to params, input. We could use some Boolean toggles to set that up. You can also right-click on P, set multiple Booleans, start adding them here, and you can even go to Manage Boolean Collection. For now, let's just use the params input Boolean toggle and try to create our own filter. Let me turn off the call nth. Now I actually don't have anything coming out of here because everything's false. If I set that to true, now you see that we have all the points coming out. Let me make that a little bit more explicit. I'm going to go to curve primitive. We'll do a circle. And I'm going to make the radius of the circle a little bit smaller, something like 0.5. Because I've set this to true, I'm going to return all of the points, and we see a circle on every single one. Let me copy this Boolean toggle, set it to false, and plug that in with Shift into P. True, false, true, false, and so on. Let's continue. Copy it once again. So we have true, false, false, true, false, false. We could continue on and on with this. This one I'll set to true. True, false, false, true, false, false, etc. This is eventually a smaller list. We come in having 100 values, And we've essentially removed half of them and we remain with 50 values. So this new list has 50 values. Everything else is thrown away. What if you don't want to throw it away and you want to keep the other points around or the other elements on the list around? Well, here in sets list dispatch, we have a component that allows us to do this. It's very similar to the call pattern, except that you get two outputs. The output A is everything that has been set to true, and the output B is everything that has been set to false. Let's plug in our points into L. I want to transfer this pattern over here. I'm going to do that by hovering over P, pressing Control Shift and click. Now I can move all of those inputs into P. Try that again. Control Shift, click, drag. Control Shift, click, and drag. That's pretty handy when you want to move a lot of stuff at the same time. Let's focus in on what's happening down here. I have this pattern. I'm going to turn off my previous call pattern, and I'm going to take my circles, and I'll plug the output of A into my circles. For now, everything looks pretty much the same, except that we're not throwing away the other points. So you see them here, and they're actually coming out of B. So let's put a different curve on that. I'll go to curve, primitive, maybe we'll do a polygon. I'll make the radius of the polygon similar. I'll just plug in the 0.5, and I'll plug the points from B into the P of the polygon. There we go. When it's true, we get a circle. When it's false, we're getting hexagons. It's useful in the case that you don't actually want to throw away the things that are set to false. Maybe you just want to filter the pattern and create two streams of data based on this true and false values. For the most part, I use this component when I'm actually calculating something and I generate a list of true and false values that I want to filter. We'll see how to do this a little bit later.